Hello everybody, my name is Mr. Joseph. Today we're going to talk about quadratic growth. So when examining this pattern, whenever you have a pattern, the first thing that you should do is just define the terms. So this is my first term, second term, third term, and the fourth one wasn't given, but I went ahead and drew it so you wouldn't have to see me struggle drawing it during the video. So when I look at this, I'm going to write how many squares I have. So I have 1 here, I have 4 here, I have 9 here, and I have 16 here. So as we can see, it increases every time. So this first one is a 1 by 1 square, the next one is a 2 by 2, the next one is a 3 by 3, the next one is a 4 by 4, and that pattern continues. So that is something that we can see. And if we keep doing this, we know for our 10th pattern, we'll have a 10 by 10, which will give us 100. But the hardest part about this is actually just making an expression. So what we're going to do here is we're going to have a variable. We're going to name it x. And we're going to say x is the term number. And by term number, I mean the term that we're looking for. So for example, if I want to find the first term, I'm going to write y equals x times x. Because I know if I'm looking for the first term, for instance, that's 1 times 1, which is 1. If I'm finding the second term, that's going to be 2 times 2, which is 4. If I find the third term, it's going to be 3 times 3, which gives me 9. So this is actually x squared. So y equals x squared is actually the expression for this pattern. And you see how beautiful that is. You see? So you can't use pink. It's too dark. So this right here is our quadratic function, and y equals x squared represents this growth right here. So it gets a little trickier when you get to this next one, because once again, if you write 4, 9, 16, you probably know the next one is going to be a 5 by 5, which is going to be 25. But how do we express this? Because if we did what we did last time and we write y equals x squared, we see this doesn't work, because if you substitute, don't forget, this is the first term, right? If you substitute 1, this doesn't equal 4. So somehow this question got changed a little bit. So I'm going to erase this, and remember that x represents your term number. So if I'm looking for my first term, and I know that x has to represent that, the way that this is different than this is the fact that it has 1 more in each row and column. So this one is going to be x plus 1, and this is going to be x plus 1. Just because we have 1 more of each. So here I can write x plus 1 times x plus 1, because when I substitute 1 into each of these, I'm going to get 2 times 2, which is going to give me the 4 that I want. So I can show you. So for the first term, it's 1 plus 1 times 1 plus 1, which is 2 times 2, which is 4. For the second term, it'll also work. We're going to substitute 2 this time because it is our second term. And we get 3 times 3, which is 9. And if you do it for the next one, you'll get the same correct response and get 16. So I want you to notice the difference between these two. The fact that that was an x, the first one was x times x, because our first term was 1. So if we had 1 times 1, it got us 1. 2 times 2, it got us 4. But when we start the second pattern, this yellow one, we notice that, 1 times 1 is not sufficient here. We have 1 more in the row, 1 more in the column. So that's why we have to do x plus 1 times x plus 1. So we're going to take this information and try to do this next one. This next one is a little vague in what it's asking. It says, what does the shape and the pattern look like? I think the first thing that we notice is this right here. It's this inside part. we just look at the black part, it's 1, 4, 9. So this matches this pattern that we saw earlier. So if we were just talking about how many black squares are in the shape, we can just say y equals x squared, because that is a pattern that we found earlier and follows this pattern. So the tricky part, and look how beautiful my part is. The tricky part is the white part. It's a little harder. So let's focus on that. So I'm going to erase this and just count how many I have. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I do this one, I believe I will get 16. So if we look at the pattern for the white part, it's 8, 12, 16. And one thing that you need to notice is that this part is actually not quadratic. This growth is linear. Each time here, you are going up by 4. So if you think about this, our constant here, what we started with, is 8. And then how many times are we adding 4? That will be dependent on which term I'm looking for. So I'm going to go ahead and I'm going to write 4, parentheses, x minus 1. So you're going to see why I said x minus 1 if you just kind of experiment. So for the first question, let's say we were just focused on the white boxes. You have to remember that your x is 1. So if I do my first term, I should get 8. If I do 8 plus 4 times 1 minus 1, do you notice how I get 8 plus 0, which is 8, which is perfect? If you didn't do the x minus 1, and for instance you did y equals 8 plus 4x, and you substituted 1, you would get 12, and this is, it's not 12. 12 is our second term, not our first term. And you have to remember that the x is always the term number that you're looking for. So that's why it's really important to include that x minus 1 part. So if I was going to write my final answer for this question, it would be y equals x squared plus 8 plus, let's go ahead and distribute, 4x minus 4, y equals, combine like terms, x squared plus 4x plus 4. So this is my final answer, and it will actually get us any term that we want. So let's just check the third one. We know for our third term, the total amount of boxes we should get is 25 if we add both the black and the white parts. So it should be y equals 3 squared plus 4 times 3 plus 4, which is 9 plus 12 plus 4, which is 25. So that's exciting. So I keep going down. We got this new cool looking pattern. Once again, if you got that good eye, you keep seeing this pattern, this 1, 4, 9. This 1, 4, 9 is equivalent to y equals x squared. And then if you look around, let's erase these. Every one of these questions have these 4 extra boxes on the outside, and they're constant. They do not change. So we can just write plus 4. And we are done with that one. And once again, if we want to check it, we know here it's 9 plus 4. We know we have 13 in total. Let's substitute 3 since we're looking for our third term and see if we get that. And yes, we do. And also another thing is, this is not only one way to do these problems. You might be able to find it in a different way. And if you do find one, I do encourage you to share it. But I'm just going with the way that I think. So when we get to this next one, this one is a really fun one. What I would suggest is that you pause the video and you try to do it by yourself first. You should always do that when watching videos. And then kind of compare and see what you got. So I'm a big color coder, so I'm going to color code the 3 on the bottom because I just noticed that these 3 never change. Then on the top, I notice that it goes from 1 to 2 to 3. And this is just me being observant. Don't have any inside information on this one. I'm just trying to just gather what I see. And then in the middle, I see that these rows are stacking and getting bigger. And I don't know if you noticed that the rows match with the term number. So for instance, this one that I'm trading right now has 3 rows, and this is the 3rd term. So that's really interesting. So number one thing we have to remember is X. X corresponds to the term number. I can't emphasize, I can't just, you just have to know how important that is, so you keep that in mind. Like, this is first term, I'm losing my words, second term, third term. So when I'm doing this, I see that the yellow, so Y equals, I'm gonna write a yellow on top. Nice and easy, just write a 3. That's the one thing that doesn't change in any of the pictures, so I know I have a 3. So I'm like, okay, cool, 3. Next, let's go with the blue. This one is not as easy at all. It's how do you define this, right? Like, you have 1 blue, then you come 2 blue, then 3 blue. So one thing that you have to remember is the fact that, oh, if I have 1, 2, 3, I can just write an X, because X always corresponds to the term. So for the 3rd term, I got 3 blue boxes. For the 2nd term, I got 2 blue boxes. For the 1st term, I got 1 blue box. And now the tricky part is going to be the pink part. So for the pink part, we got to be clever here. So we notice that if we write an X, X represents the term. So if I say X, and I let this represent how many rows I have, because remember, we said that in this first question, we have 1 row, and this 1 corresponds to the 1st term. For this question, we have 2 rows, and this corresponds to 2. So I'm going to write an X just to represent how many rows, and then I'm going to do parentheses X plus 2 to emphasize like how this is growing. So for instance, in this first one, you know X is 1. So that's why if I leave X as 1, I need to do plus 2 because you get 2 more. For the next one, if you say 1, 2, this is your new X is 2, then you're adding 2. For this next one, 1, 2, 3, this represents your X is 3, then you're always adding 2. And that's why I'm getting X times X plus 2. And then we can take all this and put it together. And you get X squared plus 2X. And then highlight like terms. And Y equals X squared plus 3X plus 3 as our answer. And once again, we should never just leave our answer. We should check it. So if I do this, I know I have 15 for the pink, plus 3 for the yellow, plus 3 for the blue. So in this one, I got 15 plus 9, which is 24. So if I plug in a 3 here, I should get 24. Let's see if I did my math right. 9 plus 6, not 6. 3 times 3 is 9, plus 3. And I get 18 plus 3, 9, 20, 21, which is 21. So that means I'm going to go up here and check my math. Of course, I can't add because 15 is plus 6. That's actually 21. So it is the right answer. For some reason, y'all, I was thinking as 3 plus 3 as 9. It happens. Goofy mistake. My apologies. I hope this helps, and I hope you have a great day.